Good morning and welcome back to our last set of notes for the semester. We are on to quadratic applications. So this is some real world scenarios where we're going to use quadratic equations. So first example we're going to look at is this really old Pizza Inn menu. I don't think you could get a pizza anywhere for 85 cents nowadays. This is from the 60s. So here we're given some different sizes of pizza and what they cost back in the 60s. So what I want to do first is go ahead and make a table. So my input would be the diameter of my pizza. So I'm going to go ahead and define my variable. So x I'm going to say is the diameter of the pizza, and that is in inches. And my y, my output, is going to be the cost in dollars. So x and y. An 8-inch pizza is 85 cents. A 10-inch pizza is $1.15. And a 13-inch pizza is $1.75. Now, with this, there are two ways we can solve this. We could go with one way that we're familiar because we're looking for a quadratic function. So that means it's going to be in the form y equals ax squared plus bx plus c. Now, previously we've done this with a matrix by writing 3 equations and then using our calculator to solve the matrix for us. So if we were going to do it that way, our equations would be 0.85 is equal to a times 8 squared plus b times 8 plus c. 115 is equal to, will be our a, and then our 10-inch pizza. And then the third equation, so I know it's been a couple days and you've slept since then when we were doing our matrices, so we'll be plugging in our y values and then our x values for each pair in our table. So to make this a matrix, our a would be 64, 8 for b, 1 for c, 0.85, 100, 10, 1, 115, 169, 13, 1, and 175. And if we solved it in our matrix, it would spit out for us what A, B, and C are. Or there's another way that we can do this, and that is in our calculator. And we're going to be working with our calculator quite a bit today, so you want to go ahead and have that handy. So in our calculator, if we go to Stat, which is this button right here next to where we usually click on X, Stat, Edit, so hit enter. Oops, got a little excited. Stat, edit, and here we're making 2 lists. We have list 1 and list 2, and this is where we're going to put in our x and our y. So in list 1, we want to type in our x values. So I already have mine here, 8, 10, and 13. And in list 2, we're putting our y values. So 85 cents, 115, 175. So once you have everything in your list, you're going to exit, go back to Stat, arrow over to Calc, and then you're going to go down to option 5, Quadratic Regression. So then you have your L1 and L2, hit enter all the way down to calculate, and then it will give you A, B, and C. So A is 0.01, B is negative 0.03, and C is 0.45. So our equation would be that y equals 0.01x squared minus 0.03x plus 0.45. So either of these methods is valid. You can either use a matrices or you can use the quadratic regression. So now that we have this equation, for part B we can answer, if Pizza Inn made a 20-inch pizza, what would the price have been? So remember, our x value is the size of the pizza. So we can plug in 20 to our x's here to find the price. So that would be 0.01 times 20 squared minus 0.03 times 20 plus 0.45. So that's going to be 4 minus 0.6 plus 0.45 And that's going to give us a grand total of $3.85. Then suppose that the menu had a colossal pizza that was $6. What do we predict the diameter would have been? So that means that our cost would be 6, and we want to be solving for x. So we can do this in our calculator by making this into a quadratic. So if we move the 6 to the other side so that it's equivalent to 0, so that would be 0.01 x squared minus 0.03 x, and this is going to be minus 5.5. And what we can do is how we were finding our zeros for our previous quadratic equations. We can do this in the calculator. So what you're going to do is go to your y equals, if this will focus, come on. Come on. So go to y equals, and we're going to input this equation here. So 0.1 x squared minus 0.03 x minus 5.5. And then in y2, we're going to put 0. And we're going to graph this. Let me adjust my window here. I need to adjust my window some more. Let's go with, there we go. So now we need to find where this overlaps. So we're going to go to second calc, intersect, arrow over, enter, enter, enter. And that's at about 25. So x is about 25. So a 25-inch pizza would cost about $6. Now, notice we do have a second intersection over here on the left. So if I calculate that, I'm going to arrow over. Enter, enter, enter. And it's negative 22. Now, think about what that would mean. That would mean we would have a pizza with a diameter of negative 22. Now, that doesn't make sense. So we only have the singular solution here of positive 25 because we can't have a negative diameter for our pizza. Then the last one on this page, the price intercept, that really just means our y-intercept because our y-axis is our cost, our price. When the diameter is 0, so if we plug in 0 to our function, 0.01 times 0 squared minus 0.03 times 0 plus 0.45. If we had a diameter of 0, this would both be 0, and our cost would still be 45 cents. So why is that greater than 0? Well, this would represent, in a real-life scenario, a one-time fee. So this could be the cost of the box, or just something that our pizza place is saying, for every pizza we sell, we are charging this base overhead price. So moving on to the next one. We are going to use our discriminant to show that there are no diameters for which the price is 0. So remember, our discriminant, we have ax squared plus bx plus c. Our discriminant is b squared minus 4ac. So I'm going to rewrite our solution for our function for the price of the pizza. So if I plug in my values, negative 0.03 squared minus 4 times 0.01 times 0.45, and I type all this into my calculator, I'm going to get negative 0.0171. So my discriminant is negative, which means that my solutions, if I were to solve this using the quadratic formula, would be 2 imaginary solutions. So there are no real numbers for which I will get a cost of 0. There's no real diameter that I can plug in to get a cost of 0. So now we're showing that a linear function does not fit the data. Now remember, linear means it's a line. It has a constant slope throughout. So let's look at our x and y's again. for our base costs. Our 8, 10, and 13-inch pizzas were 85 cents, $1.15, and $1.35. So in order for this to be represented by a linear function, our change in y over change in x, or our slope, would need to be the same across each interval. So let's look. Between the first two, my change in x between the 8-inch and 10-inch pizza is 2, and my change in y for the cost is 30 cents. So my slope for that first interval would be 0.3 over 2, which is 0.15. Now let's look at the change in the second interval. From 10 to 13, that's a change of 3. And from 115 to 135, that's a change of, sorry, that should be 75. I apologize. I wrote down the incorrect number. And that would be a change of 60 cents. So that change in y, 0.60 over 3, would be 0.20. So these are not the same slope, so it's not linear. So the change is not constant. Okay. Now the next thing we're going to do is find our vertex and use our other points to sketch a graph. Now, what we need to do to find our vertex is put this in vertex form. So I'm going to start with my quadratic in standard form, and then we're going to complete the square. So with these first two terms, I have to factor out my a, so it leaves us with x squared minus 3x. So to complete the square, I need to half the middle term and square it. So this is going to end up being x minus 3 over 2 squared. Now 3 over 2 squared is 9 over 4. So what I'm going to be subtracting outside is 9 over 4 times that 0.1, and that's going to be 0.0225. And the 0.45 minus that leaves us with 0.4275. So my vertex is HK, so that's going to be 1.5 and 0.4275. So now I want to plot some of these values so I can plot my vertex, and I'm going to go ahead and make a table with some of my other values that I know. We know that a diameter of 0 gives us still the overhead cost of 45 cents. We had those original 3 diameters for 85 cents, 115, 175, and then we also had that 20-inch pizza that cost $3.85. So let's look at our graph now, and we're going to need to scale this a little bit. So I'm going to make our x intervals go up by 10, or sorry, that's by 5, and my y intervals can be a little bit more spread out because I have smaller numbers. And we're just going to have to kind of estimate here. So there's my 0. That's about where my vertex is. 8 is going to be somewhere over here, and that is $1.15. 13 is $1.15. Oops, I apologize. That should be 85. That should be down here. The 8-inch pizza is less than $1. The 13-inch pizza is at, sorry, the 10-inch pizza is at 115. There we go. That's where I was getting thrown off. That's about 115. Our 13-inch pizza is 175. And then our 20-inch pizza was just shy of $4. And then I'm going to connect the dots with our smooth graph. Now, again, we need to think about why we're only showing the positive x values. And that's what we're going to be calling our reasonable domain. Remember, your domain is your x values. It doesn't make sense. It's not reasonable to have a negative x value here because x represents the diameter of my pizza. I can't have a negative diameter for pizza. So our reasonable domain is going to be only positive x values. Or x is greater than or equal to 0.